Kia ora team and welcome to another online tutorial. Today we're going to be looking at the 2018 Level 1 Science Mechanics exam. Okay, specifically question 1 in this video. Let's get to it. So, question 1. We have a speed time graph which shows the motion of two runners, runner A and B, okay, as they run a race. For question A, or 1A, sorry, they want us to look at the graph and see which runner has the greater acceleration in the first 3 seconds. Explain your answer. Calculations are not required, so we're not going to do any calculations. Even though we're not doing calculations, I'm going to start out by writing down the equation for acceleration to help me form my argument. So I'll get acceleration equals the change in velocity over the change in time. Okay, A equals delta V over delta T. Now, with that information, I'm now going to look up at our graph. Okay, so we're looking in the first 3 seconds, and we can see that there are differences in the change in velocity. We know the change in time is the same for them because the question's asking in the first 3 seconds. We're going to look at which has had a greater change in velocity. Now, we can see that it's runner A, as they have a greater change in velocity, both starting at 0. We can see that runner A in the first 3 seconds finishes at 9, whereas runner B is somewhere around 7.5. So how do we structure that? We'd write down runner A. A has the greatest acceleration. Now, we've given a statement here, but we need to explain our answer. So we're going to come on and say, because they have a greater delta V, or change in velocity. Okay, over the same time. Cool. And that's A done. Let's move on to B. So for this one, it says, using the graph, calculate runner A's acceleration during the first 3 seconds. So again, we're still using the same period of time, that 3 seconds, and we're going to use our equation again. From above, we already know that it's A equals delta V over delta T for our equation for acceleration. Now we're going to substitute in the relevant things. So I'm going to say, cool, what was our change in velocity? We went from 0 to 9. So I'm going to give my change in velocity as 9 over our change in time, which is given to us as 3 seconds. And we get 3 meters a second squared. Remembering to give correct units where possible. Okay, don't be lazy and just give a number. Okay, for C, or CI, it says, use the information in the graph to compare the speed and acceleration of runner A and runner B in the first 10 seconds. So we're going to calculate acceleration and velocity for the first 10 seconds. Now, to make this more possible, I'm just going to quickly shop in a picture of the graph. Okay, that's much better. Now we can use this graph down here to help us ask our question. And I've just taken this from the front page. You'll just flick back. So use the information in the graph to compare the speed and acceleration. Now, this time we're looking in the first 10 seconds. Okay, so we notice that there's going to be a period of acceleration and constant velocity for both of ours, because we can see there's a change in velocity with a change in time, and then no change in velocity while there is a change in time. So we know acceleration and constant velocity. I'm going to start out with runner A first. So I'm going to start off with acceleration. Now, we've calculated this in the previous question, but I'm still going to put down my full working just to be sure I don't make any silly mistakes. And it's going to be a change of 9 over 3 equals 3 meters a second squared. Now, whenever we make a statement for velocity and or acceleration, I'm going to say for how long. Okay, so we know that A accelerated for 3 seconds. Okay, and then, because we have a speed time graph, right, that as time increases, speed stays the same. We know that the value for the y-axis along this flat line is going to give us our constant velocity, and we can see that that's 9. Okay, and then they've gone from 3 seconds to 10 seconds, so we can say v equals 9 meters a second, okay, for 7 seconds. Cool. Let's move on to runner B. So for neatness sake, I'm going to keep a gap in my working. Now acceleration is going to equal, again, change in velocity over a change in time, but we're going to be dealing with different values here. So we're going to look, okay, zoom in on our little graph here. Now our delta V, our change in velocity for any acceleration for runner B is from 0 to 10, okay? But it's over a longer period because our delta T is from 0 to 4, okay? So we can see that this is the section we're interested in. Cool, let's get to it. So we can say our change of velocity is 10 meters a second over 4 seconds, and that's going to give us an acceleration of 2.5 meters a second squared, and this one here is for 4 seconds. Okay, cool. Now let's talk about the constant velocity. So again, we know speed time graph, the value on the y-axis for any flat line is going to be our constant velocity. Okay, so we can see that it's at 10 and it goes from 4 to 10 seconds, so for 6 seconds. So I'd say v equals 10 meters a second for 6 seconds. Okay. Now for CII, it's asking us to use the information in the graph and calculations to show which runner, A or B, finished the 100 meters first. Okay. Now we know that we're looking for distance covered in a speed time graph. We can't just look at the y-axis like we can for a distance time graph. So we're going to have to calculate the area underneath our shapes. Okay. So first off, when I do that, I'm going to identify the different shapes I'm going to have to calculate. So I'm just going to mark off any shapes that are going to require me to calculate the area, looking for triangles and squares. Okay, so for runner A, I've got 1, 2, 3, 4 calculations I need to make. For runner B, okay, I'm going to do the same, identify any shapes. Now there is going to be an overlap here, so I'm just going to do a bit of a different shape. Okay, so I've got 1, 2, and again a 3 and a 4. But they're slightly different shapes, so we'll get different calculations for those. I'm going to start with runner A, and then I'm going to move on to runner B, keeping my work as separate as possible. I'm also going to make a quick note that the area of a square equals base times height, and the area of a triangle equals half base times height. Okay, just so I don't make any silly calculations. And to remind you that this is how we actually calculate these things. For runner A, I'm going to look at my triangle below for 1, and I see I've got a base 0.5 times my base, which is 3, okay, times the height, which goes from 0 to 9, that's 1, plus my second object here, which goes from 3 to 10, so is a base of 7, and is, again, 9 high, okay, plus my third square, or rectangle, sorry, which has a base of 2, going from 10 to 12, and a height of 9, plus my last triangle, which has a 0.5 times our base, which is 2, and a height of 9 to 11, so also 2. Okay. And with that calculation, we should get 96.5 meters. So with our number here, we can already see that we know it's not runner A, but we're going to prove that by also calculating the distance of runner B. So let's do the calculation for runner B. Runner B equals, again, we start with a triangle, so 0.5 times our base, which is 4, and our height, which is 10, plus our second rectangle here, or our second shape, which is a rectangle, which goes from 4 to 10, so a base of 6 times its height of 10, plus a smaller rectangle with a base of 2 and height of 10, okay, plus a small triangle with a 0.5 times base of 2 and height of 2, okay, which for us will come out to a calculation of 102 meters, okay. So we can see that runner B has finished the race first. So we could say, therefore, i.e., runner B has completed the race first. Just give a little summary statement, just to knock off that question. D says, for each of the runner A's feet, there is a surface area of 200 centimeters, which they've given us in standard index units, 0.02 meters squared. Now it says each, and they put that in bold to give you that information, okay? Because they're trying to see if you're switched on here or not, and they've given you 1 foot. But remembering that our runners have 2 feet, so we're going to times this by 2, okay? Which sink into the track together. Remember a little hint that we've got 2 feet? The feet exert a pressure of this much. Now calculate the weight for runner A. First step, we're dealing with a pressure question, is always going to be to write down the formula. P equals F over A, where pressure equals force over area. Right. Now, area equals 0.02, right, for our individual foot up here, times 2. So, times 2, and we get 0.04 meters squared. So we have both the pressure and the area. We can do our calculation. So we'll say 1300 pascals, or newtons per meter squared, equals our force over our area, which for us is 0.04. Okay, and we're going to rearrange this equation to make F the subject of it. Okay, so we can see that it's F over 0.04. So we want to get rid of this, and seeing as it's divided, we're going to times it by 0.04. But if we times one side, we also have to times the other side by 0.04. Okay, so we'll get 1300 times 0.04 is going to give us our weight force. Okay, and if we plug that into our calculations, into our calculator, we will get F equals 520 newtons. So that's been question 1. We've looked at speed time graphs, how to infer who has a greater acceleration without making a calculation, calculating said acceleration. We then moved on and discussed relative motion for different runners. Okay, looked at the distance each of them has covered and made a statement on who would win the race. And we have calculated the pressure for the runner's feet, remembering that a human has 2 feet, so we times the provided area by 2. Okay. Hopefully this helps, team. Hopefully it helps you get out there and revise some mechanics for your exam. All the best.